Today we're going to talk about classifying polygons. And a polygon is a closed figure with the following properties. It is formed by 3 or more line segments called sides. So the smallest polygon possible is a triangle, because if you have 2 sides, you have to connect them, and if you had only 2 sides, then they would be on top of each other in order to connect. So has to have at least 3 sides. Each side intersects exactly 2 sides, one at each end point. So when they intersect, they're going to intersect at the end point right here. And this is what we call the vertex, so that no 2 sides with a common endpoint are collinear. So you can't have a side, you can't say that these are 2 sides, because then it would be 2 points on the same line. Whoops. Oh, looks like that's going to stay. And a polygon can be named by listing the vertices in consecutive order. So for example, if I would draw a polygon, and say it's A, whoops, that needs to connect B, C, D, E, and F, I would name the polygon A, B, C, D, E, F in order. A, B, C, D, E, F. No line that contains a side of the polygon contains a point in the interior of the polygon is a convex polygon. So when we're drawing a convex, all the lines are on the outside, no matter how many sides. Concave is a polygon that is not convex, which means that it can go in like this. And this right here is what we would say it contains a side of the polygon, or it contains a point in the interior of the polygon. So this is inside the polygon. So concave is inside, just like going in a cave. Equilateral polygon is a polygon with all sides congruent, so equilateral. So if I were to draw it, I could draw a equilateral triangle, which means all the sides are the same. And a square is an equilateral. Oops, that needs to connect. All the sides are the same length, and we can do the same thing with a 5-sided figure. An equal angular polygon is a polygon with all the interior sides that are congruent. So we could draw a 6-sided figure, and we would just, all these angles are congruent. We'd show that. And a regular polygon is a convex polygon. So I'll move up to a regular. A convex polygon that is both equilateral and equiangular. So by convex, we know that it cannot have an inside. And we know that, so convex, there's no point inside. It's equilateral, which means all the sides are the same length, and equiangular. So all the angles are the same, which this one doesn't look true because this looks like a right angle. So let's see if I can fix that. Nope, won't let me fix that. So if I would redraw this and make it a little bit of slant, that would be more of a regular polygon. So then all the angles would be the same, and all the sides would be the same. You can name polygons by their sides, and the first one that we have is a triangle because it's 3-sided. 4-sided polygon is a quadrilateral. 5-sided is a pentagon. 6-sided is a hexagon. And 7-sided is a heptagon. 8 side is an octagon. 9 side is a nonagon. 10 side is a decagon. 11 side we're not going to see much of, but it's a hendecagon. I don't know if I pronounced that right, but then number 12 is a dodecagon. And the nth number of sides is an entagon. So in our examples, we're going to tell whether the figure is a polygon and whether it's convex or concave. So this first one is not a polygon because these sides are not straight. So it's not a polygon. So it's neither, because it needs to be a polygon in order to be convex or concave. This one is not a polygon, because again, that's curved. Oops. Erase that. Oh. Supposed to say neither. And C would be a polygon, because all the sides are the same. And it is not going in. None of the points are going in. They're all on the outside, so that would mean it is a convex polygon. And 3 we would see these. You can see these sides are going in, so that means it's concave. Classify the polygon by the number of sides and tell whether the polygon is equilateral, equiangular, or regular. So the first one, it is a quadrilateral because it has 4 sides. And since all the sides are not the same, that means it's not equiangular. Here, since all the sides are the same, 1, 2, 3, 4. All 4 sides are the same. That means it's a equilateral. So equilateral, quadrilateral. And B would be since we have 3 sides, 1, 2, 3, it's a triangle. And then we look at the sides and the angles, and we have 2 sides that are the same and 2 angles that are the same, but we're missing this side and we're missing this angle. So it's neither a equilateral or equiangular or regular. C, we have 1, 2, 3, 4 sides that are angles that are the same, and so we're missing this angle and this angle, so they're not equiangular. And these 2 sides are different, so it's not equilateral. But we can still name the triangle. It has 1, 2, 3, 4, 5, 6 sides. So if it has 6 sides, then it's a hexagon. D, you can see that it has all the sides are the same and all the angles are the same. And it is, so that means we'll name it first. It is a pentagon. It has 5 sides. And it is equilateral, it is equiangular, and it's not concave because the sides aren't going in. So that means it is a regular pentagon. Looking at the star, all the angles are the same and all the sides are the same measure. But what we need to differentiate, it's not regular because it is concave. It's going in. So we're going to look at the number of sides. And it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. So it is a decagon. It's concave. And it's equilateral. And equiangular. Looking at the square, all the sides are the same, all the angles are the same. It's four-sided, so we're going to say it is a regular quadrilateral. And again, it's not concave, it's convex. So if it's convex, it can be classified as a regular. In example number 3, it's a sketch a convex heptagon. So that means it has 6 sides here. And concave means it has to be on the outside. So we need 6-sided figure that does not have points in the inside. A pentagon, so 5 sides, that is equilateral, so all the sides are the same. Length, but not equal angular, so the angles aren't the same. So when I think of a 5-sided figure where the angles aren't the same, it's what I drew earlier. So all these sides are the same measure, but my angles are not, because these two would be right angles, and these are not. And this would be the same. And here is your homework. Good luck.